Good morning, everybody, and welcome back to the second day of Space4Impact kickoff meeting. I'm Edoardo Alberti, one of the collaborators of Space4Impact, and I would like to introduce you to our second day. Yesterday, it was incredibly interesting for us, and it was a very, very dense. And we would like to thank all of our sponsors, collaborators, and supporters and backers for the opportunity that you are gifting us. Yesterday, throughout the panel discussions, the keynote speeches, and the startup pitches, we could see a red line coming up. And today, we would like to go further. Today, we would like to involve you, the audience, into workshop discussions to understand what are the bottlenecks of space and how to make space coming across onto non-space verticals so that we can understand and perceive and use space as a toolkit for the digitalization, for ESG, and for positive impact. To do that, we would like to start by 5 invited speeches. They will be very short, and they will be introducing the challenges that everyday users of space data, infrastructure, or services are encountering in making their life better, in creating more positive impact, and the challenges that they encounter in dealing with non-space users, verticals, and communities to make understand what is the great potential of the technologies that space could offer us. So with this, I would like to give the floor to Rijk Leiterer. Rijk is co-founder and CEO of Exolabs, was already pitching yesterday for the startup competition. He is an expert in Earth observation and data processing, and he has been collaborating with official bodies of Germany, of Switzerland, and he has been working with national points of contacts for satellite imagery. He has been involved in several projects with international organizations and also the UN. And I would like to give floor to Rijk to explain his daily challenges in dealing with non-space verticals. Thank you, Rijk.
So I hope you can see the screen now. So I will talk about a specific part of space technology, about Earth observation, like all the satellites taking images, doing measurements of our Earth. So we have a lot of satellites. We heard it yesterday, and this number of satellites will increase. So we have a huge amount of data. And this huge amount of data is a bit in an unbalance to what we do with this data. So we're collecting a lot of data, we have a lot of measurements, but creating information, extracting information out of the data, there we are behind. And it's getting even more unbalanced if you're looking for application. What we do with this information we have. So we have a lot of products on the market. There's a lot of startups around producing nice products, good products, but the application on the company, on the industry side, it's behind. Also in the federal offices, by the way. So what I want to show today, it's a bit the untapped potential of these data, what you can do, what you could do with the data, and what it needs to work with this data. And I just want to pick out one example. So what we normally see and why Earth observation has such a big potential are a lot of impacts: drought, damages, hazards, floods, but also changes in the ecosystem, in the society, etc. We know, because we understand the system, that quite often you can reduce it to 1 or 2 courses. In this case, all these examples, the course is snow. So ESA, they define these essential climate variables, the ECVs, and snow is one of these variables. And it's interesting because you can map snow from space, highly accurate. And of course, from a Swiss point of view, snow is everywhere. That's the reason why I'm in Switzerland. I spend most of my free time in the snow. But it's not only because it's nice, there's a huge market behind. Tourism, insurance, of course, all these climate adaptation stuff. Geotechnical construction companies, meteorological services, they all need information about snow. And we have a tool in space mapping snow. And that's what we are doing actually. And we cannot do it alone because it's a complex system. So we team up. For me, innovation is cooperation. Team up with companies good in weather forecast, good in hardware development, like Think Outside in Norway, or Ubimet, weather company in Austria. We team up, of course, with organizations like the ESA, Swiss Space Center, with research partners, ETH in Zurich, but also in Germany and Austria, working close together. And of course, with the industry partners in Switzerland, but also abroad, like Mountain or Outdoor Active. They use these products and give feedback. So enable a good communication, what are their requirements and what we can do. And there it's a problem. We can provide this product. Just look at this product. It's unique. Never existed before. We have a daily product of snow depth, 20 by 20 meter, everywhere in the world. Awesome. It's even more awesome. We can map the water and the snow daily on 20 by 20 meter. Not exist before. Beautiful. And now there's this red line. Who tell us or who give us information that this information we can provide is true? How good it is? For non-experts, it's really hard to see a difference between the image above and below. What is more accurate? What is good? What is bad? Impossible to say for them. So they have a problem to value also the product. To say, okay, what we are willing to pay for this product. What is the added value for us if we induce or include this product in our existing networks because we don't have it before? And they go the way of projects, grants, pilots. Low risk, let's see, it's okay, it's fine, you can survive, but it's not business, it's not scalable business. It's trend-based, we survive situation. But if we want to have an impact, we need to have a scalable business, and that needs to be funded, of course. What you could do, because the products exist, you can do a global coordinate monitoring, 20 by 20 meter every day, globally. It's possible. From technology point of view, it's possible. Why it's not used? You can do agroforestry monitoring. You can detect single trees. With some in situ data, you can say what is the yield which will income. You could do it. Why it's not used in the operational? That's the question. We need the business. It needs to be used, and then you can create an impact. But without creating a business behind, there's no impact. You have, on the one hand, all these nice products. On the other hand, people that would like to use it, but there is a missing link. It's a communication which is missing, is a common language you could share, and it's willing to risk also in something which not exists so far. So for sustainable development and to include space technology, Earth observation in the frame of sustainable development, we should not wait anymore. We should working together, we should trust each other, trust the requirements from industry, but also trust what Earth observation can do, and most important, take action. And this means take a risk, invest in these products, go take this product and include it in your own operations. Otherwise, it's always nice images and then it stops. And that's my final word, and I think I was in time. So thanks a lot.
Thanks a lot, Raik, for your intervention. You basically stole half of my questions already by your presentation. That is short but very thorough. So you say it's time to act and time to move, and you also explain some of the elements. But when it worked out, how you were able to make it work, or if I reverse the question, what does not allow the potential customer that you have or that you have identified to move? Why that they don't hang on your products?
It's a big step. So most of the customers we are in contact, they have systems in place. It's mainly in situ measurements, station data, and then they move to something, Earth observation. It's from space. It's something without control, really. And they need to find the same data because we cannot provide the same accuracy like a station data. But we have a wall-to-wall coverage everywhere in the world. So it's a different type of information, and they need to understand it. So they really need to understand about the data acquisition, and also the limitations. You can see a lot in media, oh yeah, you can detect individual peoples from space. Okay, it not works. You need to communicate these. You need to communicate that there's also with the product the uncertainty behind. It's not when I say there's a tree, it means 100% tree. If you stand in front of the tree, you have a 100% accuracy that there's a tree. If I map it from space, there's an uncertainty behind. So all these concepts related to space products, they need to be communicated. So it's a kind of consultancy before they accept, okay, it could be alternative. And that's a long process.
Thank you very much, Raik, for your insight. I hope that this understanding is pervading both the user side and the offer side in order to be able to cross-match the impedance of the discussion. Thank you very much. We go over now to William Richard. William Richard is a senior manager at PricewaterhouseCoopers Space Practices and is based in France, is acting globally. He is head of the PwC Insight from Space Solutions. And based on PwC internal capabilities in geospatial analytics, cloud computing, and data fusion, they provide in-depth expertise of Earth observation, and they support businesses in exploiting the full potential of satellite data, infrastructure, and technologies for deriving fresh insights for their advancement. Thank you, William, for your intervention.
So hello, everybody. Very nice to meet you. So today I will not be presenting a case study per se, but rather like a journey. The journey PwC has followed to create insight from space or new solution, helping non-technical end user to absorb a new development in Earth observation. Why the aim here was to really, as you were mentioning, Edo, it was to illustrate the status on Earth observation and introducing basically the major problems we have seen related to EU uptake within end users and so non-technical customers. So very quickly here, it has started with taking stock of the situation. We see new developments that are disrupting the utilization of satellite imagery, leading to a real democratization of the utilization of data. We see it in the news, we see it in the media. We have seen a lot of very nice examples of application during the COVID crisis, tracking lockdown effect and impact, tracking the impact on carbon emission using Sentinel-5P data. But we have also seen a lot of interest from private, so a lot of venture, a lot of large private investment into this field. Basically, this development can be split into two categories. So trend related to data exploitation. So we have advancement in cloud computing, in artificial intelligence that are allowing the exploitation of satellite imagery fused with other sources of data, as illustrated by our previous speaker, in a way that was not previously possible. From a data availability standpoint, now we have a lot of data, again, illustrated well by our last speakers, that we have more and more open source data available through large-scale programs like Copernicus, like Landsat, but we also have a lot of new entrants with small satellite constellation that allow basically to access way more data at a lower cost. All of this is basically leading to a strong technological push on the supply side that lead to democratization of the use of satellite data within expert community. When I'm talking about expert community here, I'm talking about really the earth science community and the defense field. So if we see this democratization on the utilization of data for this expert, this is not really entirely true outside of this community. So beside the business opportunity which is offered by satellite data to provide valuable and actionable insight for business and organization, the adoption remains very low in non-expert communities, so in agriculture, in asset management, in insurance, etc. Because what we see in our mind, we see three main factors for this. First, the company offering satellite-based products and services often lacks the specific knowledge expertise, so the vertical knowledge related to retail, to energy, to agriculture, to insurance, making hard to tailor their product and services to end-user operational needs. Organizations also that aim at developing internal capacity, very often they lack clear business demonstration and potential value proposition derived from satellite data. So having access to real cost benefit analysis where you're actually able to compare the solution and the benefits brought by the new application with Earth observation data versus other things. And for most of the business, it's very important to be able to demonstrate this through clear key performance indicator in order to absorb this new development. And finally, very often this organization that want to build this internal capacity, they lack the knowledge and the resources to efficiently absorb this satellite-based capacity. So this basically leads us to develop our solution, so PwC Insight from Space. This aim at bridging the gap between satellite data-based analytics and non-technical end users in many different fields, in insurance, in agriculture, in tax, in compliance. So we have use cases in all different domains. And how we do this, we put together three main elements. So a long-standing experience in strategy assignment related to creating value and business casing using satellite imagery, and notably performing cost-benefit analysis to compare different solutions. Strong technology capacity in cloud computing, data analytics, and data fusion. So we have a dedicated data analytics team internally, which are at the forefront of the latest development. So composed of data scientists, but also cloud architecture experts, programmer. And we have recently, so in 2017, acquired a startup which is specialized in geospatial data processing and the fusion of satellite imagery with heterogeneous source of data. And finally, the last expertise we bring, which is very critical, as you know, PwC is a very large firm with a lot of different teams in different domains. We bring on the top of the space domain or very specific domain expertise in energy, in retail, in insurance, in security that support my practice, so the space practices, in identifying the client operational needs to translate it into products that are meaningful for them. How does this concretize into a concrete offering? We have two main pillars, let's say. The first one, it's really related to advisory services. So applying these new developments to better perform or consultancy services, so in all type of domain, as I was mentioning, to better do and more accurately impact assessments, to be able to perform policy monitoring for public clients, to perform market assessment more accurately in a region where we have no statistics available, or to support development of very specific commercial strategy. So here really our target is our internal teams, so our teams in retail, in energy, and etc. And finally, the last offer we have, so it's a capacity building one, where we support external clients, so it's in general non-technical end user, to build internal capacity in order to absorb this new development, but also to advise them on the best solution on the market that will fill the gap for what their needs, including all the cost-benefit analysis and etc. we were mentioning before. In this, we have been working on specific cases, but I don't think we have the time to discuss on this. So do not hesitate to get back to me afterward if you want more details on the type of services we are doing and the type of cases. And very quickly on the challenges we are today still facing is the fact that there are two. One, it's more technical problems which are related to being able to access data with a higher revisit, because when you really look for specific geographies, you realize that even with a current data provider, it's not always easy to get a nice revisit. So having a lot of data from this specific area on bi-weekly basis, for example, being able to get 2 images per week, it's already quite complex for some geography. And also different type of sensors, the detection and monitoring of moving objects is highly interesting for us. And finally, very important point, it's really on the business elements, which is something we are facing today. And I think that's one of the main barriers for a lot of people, is the fact that it's very complex to have a pricing or a business model specific from the data provider that is able to match with what we need, because you always need to pay upfront, to pay in advance, and in general, having license to get commercial data and very high resolution, it's very expensive. Thank you very much. I hope I was not too long.
Thank you very much, William. You were very thorough in your argumentation, and I had a question to address you, but on the commercial data, but you were addressing it properly already at the end of your speech. So thank you very much, William. We go on to Farhad Teherani. Farhad Teherani is from Delta-RES and is a data-driven geotechnics researcher. He is the leader of the Natural Hazard program at Delta-RES, and his research is about integrating observation data with geoengineering to forecast and analyze the behavior of geosystems. So, Farhad, the floor is yours. Thank you very much for your intervention.
So, good morning, everyone. Thank you for your kind introduction, Edo. I'd like to bring your attention to the applied research on natural hazards that we do at Delta-RES. For those of you who don't know Delta-RES, Delta-RES is an independent research institute focusing on applied research in the field of water and subsurface. We are based in the Netherlands with multiple offices across the world. And our expertise is on flood risk, adaptive delta planning, infrastructure management, water and subsurface resources, and also issues related to the environment. Well, we have now a program dedicated to natural hazards at Delta-RES, and I am one of the leaders of that program. Our goal is to use our expertise at Delta-RES, also joint collaboration, to reduce the consequences of extreme events worldwide. There are 3 lines of research in the natural hazards program at Delta-RES. Those are on understanding of natural hazards, also on quantification of natural hazards using by providing data and tools and models, and also prevention and mitigation of natural hazards by providing locally appropriate physical measures. So the natural hazards that we focus on are flood, geohazards, wind, and erosion. So this slide can give you an idea of the type of hazard related to these hazards. So basically what can cause these hazards, and also what can be the consequence of these hazards in terms of other hazards that can be generated out of these hazards, are of our interest. Well, Delta-RES is quite well established in flood risk assessment. And therefore, in the coming years, we would like to develop ourselves further in other hazards that I mentioned here, especially on geohazards. And that's where my expertise come from, because I'm a geotechnical engineer by training. And the application of the researchers that we would like to do on performance geohazards, or at the moment we are currently busy with, is on mainly on slope instability and also consequences of the slope instability, which targets several sectors and organizations, including humanitarian organizations and transportation, mining, energy, and also agriculture. The main challenges that I see in our daily practice is the timely availability of high spatial and temporal resolution data, also with minimum atmospheric effect in form of noise and contamination. For instance, cloud contamination when it comes to optical satellite data. Within geohazards research, there are certain pillars that we are investing on, and this is the next slides that I will present to you deal with those. Understanding of natural hazards, in this case, slope instability process is an important factor in our decision-making process, also what sort of tools and models we need to address them. Therefore, creating a database of slope instability and basically engineer the natural slopes across the world is one of the goals that we have. This can be translated into landslide and dam detection and mapping. Furthermore, we would like to use space data, remote sensing data, specifically on monitoring embankments and natural slopes. So radar and optical data are the data that we are using in our daily practice. Forecasting in form of spatial and temporal forecasting is another research line that we have within geohazards research, and that involves physics-based or process-based, data-driven, including machine learning application, and also knowledge-based in form of expert judgment from our own experts in form of quality forecasting products for slope instability process. And integrating all these together is one of the goals that we would like to achieve in the coming years, because of the limitations that each of those can have. Each of these process-based, data-driven, and knowledge-based can have individually, but we think by combining them, we can surpass those limitations. To consolidate those research lines into maybe one example, some of those into one example, I can talk about this research that we have on data-informed computational models. You can think of it as a digital twins of the slope, where we are integrating monitoring data coming, for instance, from Pearson SAR technique with computational geomechanics models, for instance, finite element model, into a data fusion framework using data assimilation methods, also machine learning, deep learning methods, to basically have a better prediction for the state of the slope in the coming period, in near future. And then by detecting new data, we update our model, and this process continues. So this is one example of the research that can combine those themes that I mentioned to you. So my presentation was mainly on application of remote sensing data, and I would be happy to answer questions later this afternoon or today in the morning.
Yeah.
So thank you for your attention.
Thank you, Faraz. Thank you very much. I have to say that I've been in contact even personally with humanitarian and governmental organizations, and they were addressing that there is huge interest and huge potential for a natural hazard prediction tool, also based on satellite imagery. But it seems that nothing was really moving. Do you have an explanation why it never took off? A prediction model based on satellite imagery.
Well, I have been in contact with some of these organizations, and I think the major problem, one of the major problems that we have there is about collecting data and data management, and also communication between different stakeholders, especially the players on the field. Normally, I mean, I haven't seen a very efficient communication between these, and that means that we don't have a very efficient and timely and inexpensive data collection and data management process. I think this is one of the reasons that although there are a lot of potentials to use Earth observation data and remote sensing, but because of these problems, especially when it comes to data management, data collection, we don't see that much progress yet.
Okay, thank you very much. Thank you very much, Faraz. I give over to Marcel Hein. Marcel is CEO of the German NGO Uridu. He has been an entrepreneur of internet for over 20 years, and he has been funding Uridu in 2016 to develop Audiopedia. Audiopedia is a platform that democratizes the information access for illiterate people in rural areas. And he wants to reinvent community outreach by using digital tools. Thank you, Marcel.
Thank you, Edo. Hello, everybody. So I'd like to start off with a fact that I find quite stunning. While indigenous peoples make up just 5% of the global population, they safeguard 80% of the world's remaining biodiversity. I think that's quite something. In face of climate change and the sixth extinction, there's a growing acknowledgement of the role of indigenous peoples in biodiversity conservation and climate change resilience. The thing is, indigenous populations are vulnerable. They are facing growing threats of discrimination, marginalization, and forced assimilation. In some regions, oil firms and loggers push them to the brink of extinction. On top of that, supporting indigenous people is not an easy feat. They usually live in hard-to-reach, remote, and sometimes insecure areas without basic infrastructure. And they mostly rely on a hyper-local language and oral tradition without being able to read and write. So reaching out to those communities is a real challenge, as you can see from these pictures taken in the rainforests of the Congo Basin. If we want to support indigenous populations, we need to come up with new, innovative approaches. Our very own way of tackling this is by building a scalable solution to share audible knowledge among marginalized populations. We are calling this project Audiopedia. Audiopedia is an open ecosystem of localized digital audio contents and technologies. The goal is to support the outreach of local NGOs and community-based organizations. We are translating and recording mostly health content and making it accessible through innovative user interfaces and robust technology. Since 2016, we are using solar-powered audio players to disseminate our content. They are robust and independent from the electric grid. You can think of them as audiobooks that contain hours and hours of structured health content. The player is the perfect tool to reach out to the remotest areas of this planet. Yet in some countries, and more people are getting access to smartphones in the so-called smart feature phones. This is why we created the Audiopedia app, a mobile web application. And one of our latest developments is the Audiopedia Wiki, a decentralized collaborative infrastructure that allows organizations to share and use audio contents. All in all, we are currently at the point where we are scaling Audiopedia into large parts of the global south with the help of partners and German government funding. But as you can see, we have blank spots on our map, and there's a reason for this. Let's take, for example, a look at the Democratic Republic of the Congo. What you're seeing right now is a map of its 3G coverage. As you can appreciate, there are regions like this one, the red one here, where there's no 2G, no 3G, no G whatsoever. We're talking about 23 million people in the DRC alone that have no mobile coverage at all. The same applies to many other sub-Saharan countries. So what can we do to reach those marginalized indigenous populations? And can space tech really help us? Well, yes, it can indeed. Smart satellite phones like the Android-based Thuraya, for example, can be used to run our decentralized Audiopedia wiki infrastructure. This allows us to empower local NGOs and community-based organizations in remote areas to cooperate by uploading, sharing, and downloading locally recorded audio. Community workers would be able to share this jointly created audio content to their beneficiaries using solar-powered audio players. So what would actually the benefit be? What would actually be the benefit of this? Well, we would support indigenous populations by improving their health status, reducing disaster risks, and thus building resilience. We would be able to inform them about their rights and support their self-determination. And finally, we would keep their indigenous language and culture alive and conserve their valuable knowledge. We would kind of create an oral internet for indigenous populations. This is not like radio, as you might think. This oral internet offers a direct and structured access to its content. We are using the same principles that apply to written knowledge, basically adapting them for societies with oral traditions. I personally do strongly believe that we need unique and bold approaches like this one to tackle the challenges of our time. As a solution provider and partner of NGOs, we will definitely keep moving forward through innovation. Thank you very much.
Thank you very much, Marcel. Your speech is very enlightening, and it's not only talking and remembers us that we are not only talking about privileged countries, but there are also other realities that we should take care about. And thank you very much. I would ask you, it seems that your solution is fixfertig, is prepared, and what can space infrastructure do for you? What you see as a missing link? Can you have something affordable? What are you missing?
Well, I think the idea of having smart satellite phones is really could be a game changer for NGOs that are operating in those areas. So basically having affordable devices and affordable pricing plans could really make a difference. And this does not only apply to the solution that I just shown. There are other digital solutions that have already been developed to support marginalized populations, indigenous populations, for example, when we talk about mapping of environmental issues caused by logging firms or by oil companies. So basically having access to those using satellite phones would really change the work of many NGOs and community-based organizations, and I think would really support the resilience of indigenous populations.
Thank you very much, Marcel. I would have a question for you, but we have to proceed. I give floor now to Simone Gatto. Simone is an agronomist at Portofelloni, one of the biggest Italian farms located in the province of Ferrara, in Italy. Portofelloni has been one of the first businesses adopting Earth observation technologies and precision farming. And Simone will explain us his challenges and his results. Thank you, Simone. Floor is yours.
Thanks, Eduardo, for the introduction. I'm Simone, an agronomic technician at Portofelloni Farm in Italy, which adopts precision farming practices since 1998. Currently, we are a point of reference in the Italian agricultural sector with collaboration and consultancies for both companies as well as universities. In this slide, I will briefly describe our annual agronomic management and the technology we use. One of the most important factors for us is the study of fields variability. So we systematically collect data on our production and soils variability and transforms them into high-resolution maps with management and cartographic software. This process enables us to implement targeted agronomic strategies for our crop plants. And as I mentioned earlier, the whole company is managed with precision farming technologies. In particular, we use a satellite auto-steering as tracking system. We make variable rate application for seeds, fertilizer, plant protection products, and water. And also we use forecasting models to support decision for plant diseases and irrigation. Finally, we use ground sensors such as weather station and soil moisture probes. Furthermore, every year we analyze our strategies to increase their efficiency. A great support for monitoring our crops comes from the use of satellite or drone images. In particular, we analyze data and images from the satellite to monitor the health of our fields through various vegetative indices. Moreover, data processed by our weather station and by forecast model for diseases are integrated with this data collected also in the fields and compare this data with drone images and soils or production maps. Our aim is the creation of prescription maps for the variable rate application of different inputs, both to prevent and treat nutritional stresses or other problems. In this year of experience as an end user of satellite images and data, I have made some considerations. Higher resolution images are strongly required, being the market saturated with the data and images from the Sentinel with a resolution of 10 square meters. However, services providing higher resolution data are too expensive compared to the economic return that a farmer can benefit from them. The need for higher resolution is due to the increasing performance of agricultural machinery and the smaller working width they can manage during the variable rate application. Moreover, in high-income crops, higher resolution maps means less background noise that is frequent, for instance, in orchards and in vineyards. Another key element will be the analysis of crops' spectral signatures in order to develop new indices to detect issues related to particular pathogens and weeds or weather situation in the crops. Integrating or correlating these new indices and data from ground sensor would improve the entire agronomic process. Increasing the frequency of images is another key aspect. Indeed, in Italy and as in other European countries, the cloudy and foggy periods coupled with the timing of the satellite passage represent a problem. Finally, new vegetative indices should be developed because climate change is increasing problems related to crops, in particular due to water and phytopathological stresses. Thanks for your attention.
Thanks a lot, Simone, for concluding in time and for enabling the schedule to be precise, Swiss clock. I just have a question for you. You mentioned the need for high-resolution images, and there are several constellations out there providing higher resolution images. So why don't you just use them?
As I said before, one of the key element, the key aspect is the cost of these images or data and in particular for a farmer it's difficult to benefit to have a benefit with the higher cost. For this aspect, I want to propose to encourage countries to work at a national or regional level through trade association or consortia as cooperatives to link to have images to a cost for a farmer supportable.
Thank you very much, Simone, for your approach to the commercialization of satellite images. And I understand that you are one of the most innovative companies in Italy, but and that you could teach a lot to a lot of farms all around. Thanks a lot, Simone. Thanks a lot for your contribution.